Let's talk about percentage yield. Most of the problems that are associated with this topic, percentage yield, there are also one or another associated with this other part of the topic, percentage purity. It's easy to comprehend the percentage purity as a concept, but then percentage yield demands some specific, steps, right, for us to undergo those steps up to the moment where we get the actual or the valid answer or the response to the question. So as I said, we are dealing with percentage yield itself. So percentage yield, I think the first part, let's just differentiate these words. What do they do? The percentage yield and the percentage purity. So what do these two things do? All right, to respond or to give a response to that question, percentage yield measures how efficient a reaction is. So this one measures efficiency of the reaction. So percentage yield measures the efficiency of the reaction, while percentage purity, it just measures how clean a product is. How clean a product is. So in other words, we are talking about a quality here. So we're talking about the quality of a product. So yield measures the efficiency of a product, while purity measures the quality of a product, how clean that product is. So that's how we can simplify, we can differentiate these two words. They don't mean the same thing, they're different. So if you're given a certain reaction, you have the reactants and the products. If you are measuring the efficiency, right, of how that product has been formed, then we're dealing with what? We're dealing with percentage yield. If we were measuring the quality, how clean, does it have pure things, pure substances, is it pure, or it contains some impurities, then we are dealing with percentage purity. So that's simply how what these two words mean. So today we are actually going to deal with the percentage yield. So we should take this one out because that's not what we are doing today. We just wanted to see the differences and what do they do exactly. So percentage yield, we're dealing with percentage yield, and we've already seen that the percentage yield measures how efficient a reaction is. Now there are some words that we don't need to take for granted, take them for granted. They are supposed to, we are supposed to deal with them whenever we are dealing with percentage yield problems. So what are some of these words, or what are these words? Number one is theoretical yield. So is theoretical yield. So what is this theoretical yield? So this is simply the maximum amount of product produced by stoichiometry. Okay, so we are saying it is the maximum amount of product produced, predicted, not produced, but predicted. So this one is predicted by stoichiometry. Is predicted by stoichiometry. It's as simple as that. So theoretical yield, it is the maximum amount of product predicted by stoichiometry. That is, if the reaction goes perfectly. Remember, we are dealing with how efficient a reaction is. If it is going smoothly, all right, it is going according to how it was set to go that way. So if we are dealing with theoretical yield, we are looking at the maximum amount of product predicted by stoichiometry if the reaction goes perfectly. So most usually these kind of problems, there is a need for us to come up with the equation. Okay, sometimes we are given the equation, but sometimes you are not given the equation. We're just given these statements, and we are supposed to make the equation, to form the equation just based on the statements that were given up there. So from the equation, from the statements, we get our theoretical yield. All right, we get our theoretical yield. We calculate our theoretical yield. Now, we're not given, we're not given this. Most of the questions that come under percentage yield, we're not given the theoretical yield. We are supposed to calculate, and this is where much of our focus has to be. This is where there is much work when it comes to these kind of problems. So that's it. That's your theoretical yield. Is the maximum amount of product that is predicted by stoichiometry. So by the way, stoichiometry here, it means we are supposed to have an equation. There is something else to do with an equation there. So from this equation, it's where we'll get a clue of what we are supposed to do. All right. Okay, so that's as simple as that. Let's take it out so that we can come up with something else different here. So we were dealing with theoretical yield as one of the words or one of the terms that we cannot skip as we are doing the percentage yield. Now the second word, the second term is what we call the actual yield. Remember, theoretical yield is the one that most of the times the examiners tell us to sweat. They make us to sweat. We are trying to solve the problem for us to find the theoretical yield. We are going to have an example here. So that is theoretical yield. We sweat a lot. We sweat a lot. We solve for us to find this one. And now there is also something else, another term which is known as actual yield. So there is actual yield. So what is this actual yield? The actual yield. So the actual yield, this is simply the amount of product. So it's amount of product, not the maximum amount of product, but just amount of product. And this one is the one which is obtained, amount of product obtained in the experiment. So remember, we are dealing with experiment here. So when we are trying to define actual yield, it is simply the amount of product that is obtained in the experiment. We are dealing with the experiment. Okay, a student is investigating something, is conducting an experiment. The product, the real amount that student obtains in that experiment is what is known as actual. So it's easy to remember this one because it's like actual, the actual. So from the word actual, you get it that it is really something that is being obtained as you are doing something. So that is actual yield, amount of product obtained in the experiment. While the first one, which was theoretical yield, that was the maximum amount of product predicted by stoichiometry. While this one is the amount of product obtained in the experiment. Most of the times, or just usually, the actual yield, we don't sweat a lot for us to find this one. We are given in the sentence. So actual yield we are given, we don't sweat. Okay? While the theoretical one is the one that it takes lots of time and lots of energies for us to solve that one. So just hold on to these two words, the actual yield and the theoretical yield. So I think we are good here. Alright, so let me also take this one off this board. So what are we supposed to do? Having these two terms, it means we can formulate our equation, not equation let's say, but our expression, the mathematical expression or the formula, if you say so. So using these two words, the theoretical yield and actual yield, we can now come up with an equation that will try to connect the things that we just said. So how can we solve? How do we find the percentage yield? So percentage yield is simply equal to the actual divided by theoretical multiplied by 100%. Remember, it's percentage yield, so they're supposed to have 100% somewhere else there. So here we are saying the percentage yield, we're saying the percentage yield here is equal to the actual yield, which is this one, divided by the theoretical yield multiplied by 100%. These three must exist: the actual, the theoretical, and the 100%. They must exist in this equation and in this formula. Otherwise, you can't solve for the percentage yield. So by having this, if this one is percentage yield like this is A, this is T, multiplied by 100%, it's easy. If you are supposed to find A, you can find A given the percentage yield and given theoretical yield. You can find A here. Given this one, you can find even T. Given both these things, you can find even percentage yield. So if you know the formula, then it doesn't matter which variable you are asked to find, you can do that one easily. So that is a simple formula that we are supposed to use. Now, let's put this formula to a very good use. What are we going to do? We are going to have a certain question. We are going to have a certain question. Okay, let's try to take this one off. We don't need this. Okay, we don't need this. We can put it down there. Okay, good. So let's try having an equation. Imagine you're having this you're having this equation or question. Okay, let me try to get this question from the getting this question from the picture. I think someone else gave me this question. It's one of the questions. Okay, good. Right, try. See, check this question. Okay. It says 1A here. Define the limiting reagent. Limiting agent. It's easy, that one. Okay, but now B. Let's try to solve B. A student reacts 4.5 grams aluminum powder with chlorine gas. Right. 17.8 grams of aluminum chloride are produced. Calculate the percentage yield of this reaction. So somewhere else between chlorine gas and 17.8 grams, there was supposed to be a full stop. So this question, it's just a matter of like grammatical error, punctuation, something else to do with that. So it was supposed to be a student. I'm reading B. A student reacts 4.5 aluminum powder. So what is this 4.5 aluminum powder? What is this 4.5? It's simply mass, right? It's just simply mass of aluminum powder with chlorine gas. Now 17.8 grams of aluminum chloride. You can check. You can see here that 4.5 grams of aluminum powder has been reacted with chlorine gas. We don't know the mass of chlorine gas because it's not really important. What's really important here is the aluminum powder, because the second part we are told that the 17.8 grams was for aluminum chloride. So it's 17.8 grams of aluminum chloride are produced. So this is what is this 17.8 grams? You find out that this 17.8 grams is simply the actual yield. The actual yield, because this student is reacting 4.5 grams of aluminum powder with chlorine gas. In other ways, conducting an experiment. Okay, so remember we said that theoretical yield is the maximum amount of product predicted by stoichiometry. So here we haven't come up with the equation yet. So we'll come up with the equation for us to be able to predict the maximum amount of product by the stoichiometry. So in other way, we are going to solve for our theoretical yield for us to come up to the actual, to the percentage yield here. But now the actual yield, remember the definition of actual yield, it's simply the amount of product obtained in the experiment. So in this experiment, the student obtained or produced 17.8 grams of aluminum chloride. So that's the actual yield. This student obtained, this student produced. As this student was doing the experiment, was conducting an experiment by mixing aluminum powder, which was 4.5 grams with chlorine gas. This student produced or obtained 17.8 grams of aluminum chloride. So this 17.8 grams is the actual yield. We don't have theoretical yield here. Now the question says, calculate the percentage yield of this reaction. Calculate the percentage yield of this reaction. We are going to simply use the formula. So we go back to here. So in that question, we are given mass of aluminium. Okay, so we are given mass of aluminium. See, mass of aluminium we are given, and it says aluminum powder, that is 4.5 grams. What other thing are we given? We are given the actual yield. We are given the actual yield. The actual yield in that question was 17.8 grams. Okay, that's the actual yield. These are the things that we're given. So we are asked to find the percentage yield, but we don't have the theoretical yield. Okay, these are the two unknowns. There are other unknowns there that we're going to calculate to find them as we go through, but these are the ones that we have. We don't have the percentage yield because that's where the question is gonna end, and the response is gonna end. And we don't have theoretical yield because this theoretical yield is the one which is gonna help us for us to find this percentage yield. So we must calculate the theoretical yield. That's our priority right now. Our priority is to make sure that we find the theoretical yield, because that is gonna help us calculating or solving for percentage yield. Okay, so what are you going to do? Remember, the theoretical yield is the maximum amount of product predicted by stoichiometry. Therefore, we're gonna come up with an equation. Okay, we're gonna come up with an equation. So what's the equation going to be like? What is this? Okay, let me just also take this one off. Okay, yeah. So what is the equation going to be like? The equation here is going to be like aluminium is reacting with chlorine gas. So simply write the things that are given in the sentence. They say aluminium, you write your aluminium, Al, is reacting with chlorine gas. Remember, chlorine gas is Cl2. Is giving us something. What is it? It's giving us aluminum chloride. So here, aluminum chloride, how are you going to come up with aluminum chloride? Remember that aluminum is 3 plus on top there, and chlorine is just 1 here. So what are we going to do here? What are we going to do? It's simply remember that we put 3 here, we put 1 here, and then there is something else like this. I don't know if you remember that. And then the aluminum is gonna have only 1, and the Cl is gonna have 3. So simply we're going aluminum chloride like this. So that's our aluminum chloride. So we're going to have aluminum chloride like this. Okay, so Al plus Cl2 giving us AlCl3, right? Now CO2, remember that it's in gaseous form, but when we are writing it in form of the ions, this is how we're going to write it in form of the ions. Okay, good. Now let me take off some things like this. Anyway, this 2 again, I'm gonna put it there. After writing the equation, the second thing is to make sure that in chemistry, make sure that that equation balanced. Does it match? So make sure that you balance the equation before even you go further to the question, like for you to check what is the next question. Make sure that you balance it. How are you going to balance it? Let's see. We have Al, it's 1 here, Al, it's 1 here. So it's 1 here and it's 1 here. But then the Cl, we are having a problem. Okay, remember that I removed 2 down here. I need to, yeah, like that as a gas. Okay, so go back. Aluminium is 1 here, aluminium is 1 here. Okay, we don't have a problem, but we have a problem with this. We have a problem with this. We have CO2 and we have CO3. What are we going to do with that? Okay, so this is simply because this is 2 here, this is 3 here. It is simple if you multiply that one. Okay, if you multiply this one and this one to make 6, and therefore it's gonna be okay. So what are we going to do here? It's simply let's say, if you put 3 here, we're going to have 6. So 3 multiplied by 2, it's 6. It means for this one to be 6 again, we're going to put 2 here. So you're putting 3 here because if you multiply this one by this one, it's simply 6. So because it's 6, we are also want to make sure that the chlorine here, there are also 6 of them. So we just have to put 2 here. When we multiply with this one, it's going to be 6. So we are good. But aluminium here is 2. Here it's 1. So we just have to put another 2 here. So it's well balanced here. Okay. If you forget about the balancing things, go back to the basics of chemistry. You're gonna know how to balance that. So again here, first thing, let me move this one first, and then I'm gonna come up with another one. Okay, good. All right, so what we simply did was to come up with the balanced equation. So it was aluminium plus chlorine gas giving us aluminium chlorine, and we put 2 here, we put 3 here, and we put 2 here. So that's a balanced one. That's the first thing. The second thing is to go on and try to solve the problem. Okay, how are you going to solve the problem? We said that our task is to find the theoretical yield of the product. Remember, we're dealing with the product here. Okay, so what are we given? If I remind you again, we are given the mass of aluminium, and the mass of aluminium, it's simply 4.5 grams. Okay, let me do this. So 4.5 grams, and this is mass. And we are given this one, the actual one, and the actual is 17.8 grams. These are the things that we're given. So what are we going to do here? It's simply trying to find the number of moles of this. Remember, the actual yield, have you seen the actual is in grams? Therefore, the theoretical one, the theoretical must also be in what? In grams. So these yields are masses. So the yield is a mass here, and the theoretical yield, we are supposed to find it as a mass. But here we're given the theoretical yield that we're coming up here, the theoretical yield is for the product. This actual yield is also for the product. So it means we are trying to find, or to make sure that we find these things for the product. The theoretical yield that we want to calculate here, we want to calculate the theoretical yield for the product. The actual yield that we have been given here is the actual yield for the what? Product. But here this mass is the mass of the what? Of the reactant. So we must make sure that we find the theoretical yield using this mass of the reactant. The theoretical yield of the product using the mass of the reactant. So let's do that. How are you going to do that? Remember, in the definition of theoretical yield, there is something else to do with predicted by stoichiometry. In stoichiometry, we look at the ratio. Okay, so we're going to look at the ratio of this and the with what? With this. So the ratio of the reactant and the ratio of the product. I mean the ratio of the ratio between the reactant and the what? And the product. That's what we're going to do with. So I hope you are following me and it's easy to follow me in that way. Okay, I'm trying to be slow enough. Okay, good. Now here we already have 4.5 grams, but here we have 2 moles and here 2 moles. So let's do with the masses first, and then we continue doing the other things. All right, let me also take the whole of this off. I'll keep on writing the formula, not the formula but the equation itself. Okay, good. Again, the equation was aluminium plus CO2 giving us AlCl3. There is 2 here, there is 3 here, there is 2 here. Okay, good. Now what are we supposed to do? This is how we are going to finish, or we need to continue solving it. So we want to find the number of moles of aluminium, because if you find the theoretical number of moles of aluminium, we are also going to find theoretical number of moles of what? Of aluminium chloride. So how do we do that? Remember, the moles, I mean the mass is 4.5. So the number of moles of aluminium, it's simply how do you do it? Mass number over molar mass. Mass number over molar mass. Remember, we are dealing with the aluminium. We need to find the number of moles of aluminium for us to find the number of moles of what? Of aluminium chloride. Okay, using the ratio. But for now, we're not using the ratio. We are simply calculating the number of moles of aluminium. So what is it? What is the mass? Mass is 4.5 grams. What is the molar mass of aluminium? Molar mass of aluminium, if you check your periodic table, it's around 27. Okay, it's around 27 grams per what? Per mole. So 27 grams per mole, while the mass is just 4.5 grams. So if you do this one and this one, this is gonna give you something else like 0. So 27 into 4.5, it's 0.167 grams. So you're going simply to find this answer. So 4.5 grams divided by 27 grams per mole is equal to 0.167 grams. That's not the grams actually. So we cancel grams, we're going to find to remain with moles. So pardon me, we are going to find with the moles here. We remain with moles, so not grams here but moles. Okay, good. I think we are together there. So 4.5 grams divided by 27 grams per mole, we are going to find 0.167 moles, not the grams as I said. Good. Now that is the number of moles of our aluminium. Okay, so I'm gonna take these ones off. Let me see if I can undo all these things, or it's gonna take time. Okay, let me see. All right, good. So the number of moles of aluminium for this one is 0.167 moles. You've seen how we've calculated that one. Good. Now let's find, that is theoretical number of moles of aluminium, right? Let's find the number of moles of this one, because whatever we're doing, we want to deal with the aluminium chloride. So we are going to use the ratio. So you can see that 2 moles, okay, 2 moles of aluminium is giving us 2 moles of aluminium chloride. Okay, 2 moles of aluminium is giving us 2 moles of aluminium chloride. So this is just 1-to-1 ratio. So if it is 1-to-1 ratio, whatever the number of moles are for the aluminium, the same as the number of moles of what? Of aluminium chloride. So the number of moles that we found in aluminium is 0.167. So 0.167 moles. These are also going to be the number of moles for aluminium chloride, which is 0.167 moles. How do we know that? We've known that using the moles. because according to this, to these things here, for you to read this, you say 2 moles of aluminium combined with or reacting with 3 moles of chlorine gas is giving us 2 moles of aluminum chloride. So it's another way, in a simple manner, is 2 moles of aluminium is giving us 2 moles of aluminum chloride. So if it is 2, it means if you calculate the theoretical moles of this one, it's 0.167 moles. Since it is 2, or 1, it means 0.167 of moles of aluminium is giving us 0.167 moles of aluminum chloride. It's as simple as that. Okay. Therefore, we know now that the number of moles of aluminum chloride is 0.167 moles. So I'm gonna take this one off again. Let's see if it's gonna do it or it's gonna take time. Now it's happening. Okay, good. So now we know. Okay, now we know that 0.167 moles of aluminum is also giving us 0.167 moles. Good. Why are we trying to find the moles here? We are finding the moles here because we want to use these moles for us to calculate the mass. And remember, the theoretical yields and the actual yields are in masses. Their units are masses. So we want to find, that's why we were trying to find the number of moles here to relate them with this number of moles this side, so that we can have this number of moles and we can use this number of moles for us to find the mass of this. So it's simple. For us to find the mass, we must, you know the gist, we must know the molar mass of this one, okay, which is the formula mass of this one. So if you look at it, it's 2AlCl3, okay, like that. So if you do this, it's simple. Let's see, let me take this one back. Where's my calculator? Right, I need to find the calculator here. Okay, so let me see. Okay, so we just have to find the molar mass of chlorine. So the molar mass of chlorine is 35.5. That is the molar mass of chlorine here. Okay, good. And the molar mass of aluminium is simply 27. Okay, so for us to write the whole of it, we're going to have it like aluminium chloride. This is aluminum chloride. Okay, remember, since we already used these tools, this time we are not using the 2 here because it's simply a coefficient, so we don't need to use that one. So molar mass of this is simply 27 plus 35.5 times 3. Okay, let me just write that one. I'm gonna take that one again. Okay, so it's 27 plus 35.5 times 2. Okay, here, simple as that. Remember that chlorine is 35.5, and then not times 2 but times 3. 35.5, and then we have this number down here which is 3, so we are multiplying this one by 3. We have aluminium here, this is simply 27. So if you do this, the whole of this is gonna be something else like 133. I think so. Okay, where's my calculator? Yeah, it's 133.5. 133.5 grams per mole. So that's how we can do it. Try it on your own for you to calculate or to find the molar mass of this. So that's the molar mass of that. So molar mass of this one is equal to, is simply 133.5 grams per mole. Okay, that's molar mass of aluminum chloride. So because we know now the molar mass and we have the number of moles here, it's easy for us to find the mass. So for us to find mass of this one, we just simply do number of moles multiplied by molar mass, which is equal to this number 0.167 multiplied by 133. Okay, so it's as simple as that. So if you do that, mass is equal to 0.167 mole multiplied by 133.5 grams per mole. So this mole is gonna cancel with this mole, and if we multiply this and this, we're going to find a number, and that number, the unit for that number is gonna have grams at the end there. Okay, so remember that we are trying to find the theoretical yield, and this mass that we are finding here, it is our theoretical yield. What have we done? Our theoretical yield is the mass that we're going to find here. So simply put, if you multiply this one, okay, if you multiply them, I think you're going to find something else like what is the answer that you're going to find? You're going to find something else like 22.3. So the mass is equal to 22.3 grams, and this is your theoretical mass. This is your theoretical mass. So let's see. That's your theoretical mass. What have we done? If you look at what we've done, it's simply finding the, okay, we are given the 4.5 for the aluminium. Okay, we're given 4.5 grams for aluminium. We used that 4.5 grams to find the number of moles here. By using the molar mass of aluminium and the mass of aluminium, we found the number of moles. And from there, after finding the number of moles, what we did, we used the stoichiometry, the ratio, for us to find the number of moles of aluminium chloride, of which, because it was 2 to 2, which is 1 to 1, the number of moles for aluminium, it was the same number of moles for what? For the aluminium chloride. After finding the number of moles of aluminium chloride, we calculated the molar mass of aluminium chloride. After calculating the molar mass of aluminium chloride, we used the number of moles, all right, here that we calculated, we found from the ratio. We used the number of moles and the molar mass for us to find the mass. And this mass, it is this one here, and this mass is this mass here down, which is our theoretical yield. Because if you multiply this, you're going to find 22 point something was like 3 grams, and this is our theoretical yield. Okay, so I hope we are clear here. Now, since we found our theoretical yield to be 22.3, we are going now to apply this to our question. Oh, we already solved it down here. So we're going to apply this to our question. What is our question? Our question is to find the percentage yield. Okay, so our percentage yield, remember the formula is actual divided by theoretical multiplied by 100%. Okay, so if we use this formula, we know, or we are given our actual. Remember, our actual is coming from where? Our actual is coming from the question. So our actual was something else to do with 17.8 grams divided by the theoretical one. Theoretical one here is the one that we just found, 22.3 grams, and then we multiply this one by 100%. Okay, so if you multiply this one by 100%, we are basically going to find something that is what? If you multiply, let's multiply. If you multiply, okay, let's see, 17.8 divided by 22.3, and this one multiplied by 100, 79.8%. So the answer is going to be 79.8% and this one is a bit equivalent to just 80%. It will depend with whatever the command is there. If you are told to put it to like some significant figures, you're gonna do that, or decimal place, you're gonna do that. But if you're not told anything, just leave it the way it is, or simply doing this one, you want to lose any marks. So that's 79.8%, and which is equivalent to 80%. So that's basically how we solve this problem. Okay, that's basically how we solve this problem. So feel free to start over, stop wherever you think like you can stop, try to solve it in your own, and do your own magic behind it. So that's how we deal with the questions that are supposed to be answered under the topic of percentage yield. It's almost every question. If you check so many questions, you still use these very same methods. All you have to know is, given your reactants and you're given your product, most of the times when you say percentage yield, we are looking at the product side. Okay, we are measuring the efficiency of the reaction. And how do we measure the efficiency of the reaction? We look at the product. What do we look in the product? We look at the maximum amount of product that has been predicted. Okay, how much? Okay, how much more, or how much is the product itself? That's number one. We look at the maximum amount of product. All right, and we call this theoretical yield. Number two, under percentage yield, on measuring the efficiency of reaction, we look at the amount obtained in the experiment. All right, so the experiment, someone else is conducting experiment. What is the amount that person obtains in that experiment? Right, that gives us the actual yield, because it is what is happening at the ground, it's what is taking place at the ground. So if you find, if you are given, mostly you are given the actual yield, because you're given that experiment is blah 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 blah, blah like that. Okay, and then you're given your amount that has been obtained in the experiment. That is actual one. All you have to do is to calculate the theoretical yield. And how do you do that? You write the equation. You're given maybe the mass of the reactant, find the moles of that, try to relate the moles, the ratio of that reactant to the, the number itself of that reactant to that of the product, especially the coefficient. Okay, so if you find the certain relationship, do the mathematics that multiply with the number of moles that you calculated in the for the reactant, you find the number of moles of the what of your product. Use this number of moles and the molar mass of the product to find the mass. The mass that you find, that is the theoretical yield. And then, because you're already given the actual yield, punch into the equation, the formula for the percentage yield, which is the actual yield divided by the theoretical yield multiplied by 100%, then to find the actual percentage yield itself. The same using the formula. If you are not given the actual yield, okay, you can just still solve for the percentage, for the theoretical yield. You solve for the theoretical yield. If you're not given the actual yield, you might be given the percentage yield. So let's say you're given the percentage yield, you are given you've solved for the theoretical yield, you found it, and then all you have to do is to just punch into the equation to find the unknown, which in this case your unknown will be the actual yield. You're going to find it. But the questions of such nature, they don't usually come. These are the ones that come, that demand you to calculate the percentage yield. For the percentage purity, it's easy, right? We kind of talked of percentage purity. So for the percentage purity, it's simply easy. It's a matter of pure substance, or the amount of pure substance. So something has to do with pure here. Percentage. Okay, let me use blue. I don't know. This is green, not blue. So percentage purity. Purity is easy. You just have to find the pure substance, like the amount of the pure substance divided by the sample. The amount of the pure substance divided by the sample itself, and then you multiply this one by 100%. As simple as that. Okay, so this is the for the percentage purity. It's easy. So you are given the pure substance, so you calculate it, which you can do it some other time, and then you just portion of that, and then you divide it by the whole sample, and you multiply it by 100%. So it's as simple as that. That's percentage purity. And remember, the percentage purity just measures how clean, all right, a product is. It measures, it highlights the quality of a product, while the percentage yield measures how efficient a reaction is, and it uses theoretical yield and actual yield for it to find out, for us to find out the percentage yield. So percentage yield uses theoretical yield and actual yield, okay, for it to measure how efficient that reaction has been. All right, so thank you very much for following it up to the end. Feel free to ask questions and also to solve in your own whenever you have that kind of free time. Thank you.